Welcome. Today we are going to blow your minds and expand the number system. So go ahead and do this investigation question here. So you're going to solve this 8 times x plus 3 quantity squared plus 16 equals 0. Go ahead and pause the video to do that. All right, so let's go ahead and subtract 16 from both sides. So we've got 8, x plus 3, quantity squared, equals negative 16. Let's divide everything by 8, and we'll get x plus 3, quantity squared, equals negative 2. And I'm going to square root both sides. Get x plus 3 is equal to plus or minus radical negative 2? What? At this point, you might be like, we can't have that, right? So at this point in the past, you probably would have said, no solution. We can't do this, right? So some quadratics, when you go to solve them, you get something like this. We've seen what this looks like graphically, right? So, look something like this, right, where it's not coming in contact with the x-axis, and you couldn't solve this. But to remedy this issue, mathematicians got a little creative, and they created what's called the imaginary unit, I. So notice how I write my I a little bit different when I'm talking about the math I, right? It's a little squiggly, right? When I was writing I's in the word imaginary, they're just printing, it was a little bit different. So what this does is I makes it so that we can simplify these radicals that have negative radicands, and we can expand the number system to be so much more than we thought before. So I is equal to the square root of negative 1. All right, so what we do is anytime we have the square root of a negative number, we take out a negative 1 as a factor like we would with a perfect square factor normally. Because we can take the square root of negative 1 now, we know that is I. If I were to square the square root of negative 1 to get I squared, I would just be left with negative 1, right? So take negative 1 squared. All right. I cubed, following the same, is going to be negative I, and I to the fourth is going to be 1. All right, so let's just go ahead and get our feet wet a little bit, wrapping our minds around these, and just simplify some radicals. And so here I've got the square root of negative 9. We can think about this as the square root of negative 1 times the square root of 9, much like we've broken up radicands in the past and factors so that we can take out any perfect square factors. Well, I know the square root of 9, right? That's 3. But I also now know the square root of negative 1. That's I. So we would write the square root of negative 9 as 3I. All right, let's look at another one. Here, anytime I see that negative, I know I'm going to use I just bring that factor out first. Now, 20, I know I can break up as 4 times 5, 4 being a perfect square. All right, so if I take the square root of 4, I know that's 2. I know the square root of negative 1 is I, and I'm left with radical 5. All right, this one, no eyes floating around in here, just practicing. So 48 is not a perfect square, but we know that 6 times 3 gets us 48, and 16 times 3 gets us 48. 16 is a perfect square. So this will be 3 times 4 times radical 3, or 12 radical 3. Right, so it's just like a little bonus extra step in simplifying these radicals. Now here's the mind-blowing part. The addition of the imaginary unit creates this whole new number system called the complex numbers, or the complex number system. So far we've always talked about real numbers, but real numbers are a subset of this complex number system. Your complex numbers are written in this form a plus bi, so this whole thing is one number. That whole thing is one number. All right, so this a here, that's what's known as the real parts, right? Because it's a real part. This bi here, this is the imaginary part, because that's, well, got the imaginary unit I. And a and b are real numbers. All right, pretty cool stuff, guys, not gonna lie. Now, just like when we've talked about new operations in the past, like square roots, even, for example, we have to think, how do these guys work? How do we just do operations with them? How do we use them? So to add and subtract complex numbers, it's just going to be like combining like terms. So real part with real part, imaginary part with imaginary part. To multiply complex numbers, we're just going to distribute. Use the distributive property. Kind of like working with binomials. All right, so here we are adding, we're going to add real part to real part, imaginary part to imaginary part. So we'll get 2 plus 5 is 7, and 1i minus 3 i's is going to be minus 2i. All right, next one. We're going to have to distribute versus negative. So I'm going to have negative 7 minus 6i plus 8i. And again, poor negative 7 doesn't have any friends, but we have these two imaginary parts that we can combine here. So we'll have negative 7, right? No friends, plus 2i, that adding those real parts together. All right, we're going to get into some multiplication here. So I'm going to take 5i, I'm going to distribute both terms there. So 5i times 1 will just be 5i. And then 5i times negative 2i is going to become negative 10i squared. But remember, we know something fancy about I squared. We know that that is negative 1. So for this to be fully simplified, we're going to replace this I squared with negative 1. So now I've got 5i minus 10 times negative 1, which will just be plus 10. So I'll have 10 plus 5i, because we like to have the real part first, followed by the imaginary part. All right, this next one here, question D, is our first multiplication of two fully complex numbers with real and imaginary parts. And we're going to double distribute, or BOIL. So this will look like 2 times 1, which is 2. 2 times 3i, which will be plus 6i. Negative 12i times 1, which will just be negative 12i. And negative 12i times 3i, which will be minus 36i squared. And don't forget, we know the I squared, right? That's really negative 1. So let's go ahead and replace that. So we'll have 2 plus 6i minus 12i minus 36 times negative 1. This can become plus 36, right? So most will be plus 36 plus 2, so that'll be 38. And then these imaginary parts will have 6i minus 12i. That'll be minus 6i. All right. Over here we have negative 6 minus I plus 3 plus 7i. Again, we are just adding here. So we'll add real part, imaginary part, imaginary part. So negative 6 plus 3, that's negative 3. And negative I plus 7i will be plus 6i. All right, let's look at F here. Can distribute this negative. So we'll have 3 plus I minus 17 plus 2i. Don't be fooled there. Make sure you distribute the negative when we're subtracting to both parts. So now we're going to have 3 minus 17 and I plus 2i. So we'll have 3 minus 17, this can be negative 14 plus 3i. All right, go ahead and try these last 3. They're all multiplication. And then come back, right? Pause the video. Try this on your own. All right, welcome back. So this one here, I love. These guys are conjugates. So what conjugates mean, you might remember from working with multiplying binomials, like a difference of squares. That's an example. It's 3 and I, right? But this one has positive sign and this one has a negative sign. And so what's going on? Oh man, this happens to me when I'm teaching too, and my scribble erase doesn't scribble erase. All right. What happens is our middle terms will cancel out. So I could FOIL here, but I know that I'll end up with a plus 3i and a minus 3i in the middle. And so what I'll actually do to save some time is just square the leading term and square the last term. So this will be, let's see here, this will look like 9 minus I squared. And the cool thing about conjugates in complex numbers is that I squared is negative 1, so I'm going to end up with only a real product, which is kind of cool. So this will become negative 1, or this will be 10. Pretty cool, huh? All right, so here you could think about how this is a perfect square trinomial, right? So we know how it'll expand, but if it helps you, because you're just still thinking about the kind of ugliness of and newness of the fact that these are complex numbers with imaginary parts, you can rewrite it as being multiplied by itself in FOIL. So I'm going to end up with 9, right? Negative 3 times negative 3. I'll end up with negative 6i. and another negative 6i. So I'll have 2 negative 6i's, or negative 12i, plus 4i squared. And you might be able by now, since we know that I squared is just negative 1, to jump to making that a minus 4, right? So I'll have 9 minus 12i minus 4, or 5 minus 12i. And last but not least, we've got 2i. Gotta distribute it here. We'll have 10i. Oh, my I got a little gnarly there. 10i minus 2i squared, which will just become plus 2i. So I'll have 2 plus 10i. All right, everyone, I hope you enjoyed your journey into the complex number system. And from now on, when we are solving quadratics, right, it is fair game to be able to solve them with an imaginary number, right? So no longer are we saying, when we get that negative under the radical.